Welcome at the Masters of the Code channel. In today's video, I will show you how to install your own RocketChat server. Let's start from the example. I've already started some containers, as you can see here. So I have MongoDB here for the RocketChat. I have RocketChat app container and also nginx reverse proxy here, so I can use SSL combined with Let's Encrypt. I've also logged in to the web UI here with administrator user, and I also have Android emulator here, at which I've also installed Android version of the RocketChat. So let's minimize it. I want to show you quickly how it works. So we will send some test message to test user logged in at Android, and we have notification. As you can see, it works. And also we can send something from the test user. As you can see, we have also notification in Firefox. It's that simple. Of course, we can also send some photos and images. And why I've chose to use my own RocketChat server, I'm also using WhatsApp, Facebook Messenger, Signal and other applications. But for example, Facebook Messenger or WhatsApp, the privacy is not good enough for me. Those are the cloud services. So in all cloud services, you have to give up privacy because someone else can have access to your private data. And in other applications, like Signal, for example, you have pretty good privacy and security, but you have to give up functionality. So you, for example, can't access centrally stored history, for example, and if you lose your device or clear your application stored data, you can't access historical messages. So to countermeasure that, I've chosen to run my own RocketChat server. If you are interested in that topic, subscribe my channel and also hit the bell icon to get notified about my future videos, because in the next video I will also show you how to integrate Jitsi Meet video conferencing software with RocketChat server. So let's start. Right now I will show you how to configure it. I'm already logged in at my virtual DSM here, and let's start from cleaning previous containers. I will remove it with force option here, those three containers. So it's database, application and reverse proxy. I will also power off the emulator here and also quit the container for the emulator, and I will remove the container also. So we have those containers removed. I will also prepare the address here for the RocketChat. We will need it to configure it from the scratch. I will also check and remove the images here. So let's check again. As you can see, the images had been removed, but we also need to remove that. We have one container started, and yeah, it's that one here, used for build RocketChat application. So we have to remove it first. I forgot to do that before. Now we can also retry the command used to remove those images. So remove image, and now it worked. I will also move the configuration for the RocketChat for the Docker RocketChat aside. So we will start from the scratch. But I will leave it there to compare newly created permissions and owners for the new directory later. So now everything is prepared, and here you have that script I've already showed you in the previous video about nginx revert proxy combined with Lua script. So it works the same here, and you have of course configuration for the RocketChat, but we have also some additional directory here. It's called build_apps, and we have rocket.chat here. And that directory is used to build the RocketChat application, and also we have subdirectory here to build the Android application, so server and client. And also we have third directory called tools here, and one additional script. So let's see what's inside that script. Action helper. That script contains some additional functions, some simple ones used to run, remove and execute something in the container, but also function used to trigger some action based on the option passed to the script, which includes that script. Let's take a look on those actions. So you have build, which is simple docker build action, run exec, and also assemble. And that assemble action is used to build the application. So first, when we have the image build, it uses that image. So we have environment ready to build. And also here we have that part, and that I notify stuff in the Linux kernel is something that lets you notify processes, applications about files which had changed. And that parameter, max user watches, lets you limit the number of those files which are monitored. So the standard value for that is usually low, like 8096 for example, and we are saving that previous value here and setting the new one. It's the almost max value for that parameter because it's needed by the application build process, and also for Gradle inside the container used to build Android application. Then we are removing the previous container, running new one. We are waiting for that container to be ready, and then we are just starting building script. And at the end, if it ends with success, so it's a zero exit code, we can copy build package outside from the container, and then of course remove the container and restore those files watches. Now we can also switch to the server build directory, and we can check what we have here, and we have that action.sh script, inside which we are checking the current script path, and we are including the previously showed script and initializing some variables. So we are passing the container, the image name used to build the application, working directory inside the container, building script name, the output for the application package, and build target. So after the application is being built, the package will be stored inside the current directory, and here is the name for the output package. And then we are passing control to the function in that helper script, passing the action from the current script. So it's the first parameter passed to that script. And I can also show you that the same stuff is being used for the Android build process, but you have some other parameters, like of course image and container and paths. Besides that, we have here also Docker file. The Docker file looks almost the same like for the nginx image I've showed you in the previous video. So we have some installation process for packages we need here. That image is also based on the latest Debian standard stable version. We are also doing some stuff we need, like adding new user and adding it to the KVM group. This may be not needed in that container, that image, but it's needed to be able to start the emulator in the container used to build the Android application. So there we have the same stuff. And also we have to prepare some directory for scripts and copy the sudo file. The sudo file I will show you later gives possibility for the master user to switch to the root user or run any command is needed. So it's the full sudo profile. And also we need to copy the build script here. Then we are defining some paths. We are adding that bin path to the environment variable. We are switching to the master user inside the container and running next commands from the master user here. We are using also the pre-configured sudo profile. We are adding something like that, so when user enters the container, the current directory is being switched to the home directory of the user. And we are also installing Meteor, which is needed to build RocketChat server application. And for the command used to start the container, we are using sleep with infinite parameter. So that container will run indefinitely, and we want that because we also want to just tap to that container from the separate script. So that's the Docker file, and also we can check the sudo profile. As you can see, master user can execute any command here, and we can also take a look and build script. And in the build script, we have cloning from the Git repository from the master branch. So it's the stable version of the RocketChat server. And we, after RocketChat is being cloned, we are entering the directory. Then we need to use Meteor npm install, and we can start the build process here. You can also see that previously I've also cloned the develop branch to the separate devel directory, and I've used that because RocketChat server have that bug. It couldn't send notifications with proper parameters for Android, and I needed to copy some file from the devel branch, and also I needed to fix it my own. So I had to add priority high parameter to that gcm.js file, because without that parameter, when Android device had been idle and had entered deep sleep, the messages had been delayed, and delayed by even few minutes. So that parameter is needed, but luckily RocketChat devs added it finally to the master branch here. So it's not needed anymore. But that approach can be of course used to fix some other bugs, especially if those bugs hadn't been fixed yet at the Git repositories. So right now I'm going to show you the whole process for preparing the image used to build the RocketChat server application and the build process. But for that I will switch to my laptop here, and let's check images here. I don't have any container running right now. I will switch to my laptop because it's painfully slow under virtual DSM. It's acceptable at my NAS, but for unattended automatic process. But for that video, I like to run it quickly. Of course, you can run it wherever you want, so either on some server or NAS or even on your laptop, because it's only the build and application preparation process. So we have to switch to RocketChat server build directory, and we can first build the image for building application. So that's the image part done, and when we have the image built, and As you can see, it's being built. We can just use the assemble action to build the application package. So, as you can see, we have the application built, and as you can see, here is the newest file. And now, if we want to use that file, I would have to copy it to my virtual DSM, so I can use it. But I already have that version here, so I don't need to do it. If you build it on the other server or on the laptop, and you want to use it in the other place, you will have to copy that package. So now let's get back also to the Docker manage directory config.d RocketChat. So here we have the whole configuration, whole files needed to build and run RocketChat server. So let's start from the build file here. In the build file here, we have configuration and build commands for 2 containers, for 2 images. First, we will build nginx reverse proxy with let's encrypt image, and then in the subdirectory we have also Docker file needed for building the application image here. And as you can see, we are also copying application package first to the current directory, so the latest build is being used here. Then we are also building the application image, and after that we are removing the package from the current directory. And by current I mean that one here. We have also script for cron responsible for renewing certificates under let's encrypt. So here you have parameters. It's also configured by environment variables, so you don't have to change it here. Next file is file we've already seen in the nginx container in previous video, responsible for cleaning old images. We have also that file containers.list, and here when you have in my manage script, when you have application that contains more than one container, you need that file to specify names of the containers, so the script is able to handle it properly. So here are just names of the containers. And the next one, create.sh. In that one, we are additionally defining new Docker network. It's especially important to configure it for Jitsi Meet, but we are using the same separate network, and also the separate network gives possibility in Docker to resolve container IP by using its name. So that's the additional functionality. So without defining new network, it wouldn't work properly. And also I will show you later, or maybe in the next videos, why also I defining additional network for other purpose also. Next you have docker create commands. So we have 3 containers, as you can see here, and the standard configuration. So for the MongoDB we are using standard image here, not building one. We are mounting volumes here and setting network and some other options. For the application container we need to define some stuff like domain, port, etc. So you need to change it, of course, for that. And for the reverse proxy we need to specify also the local address of the RocketChat application, as you can see here, email for the let's encrypt, and domain, which is available from outside, of course. Next we have Docker file, and it's the Docker file for reverse proxy, and it's really similar to the previous video nginx Docker file, but in that one we additionally install certbot using pip3 module from Python, and also it's important to install cryptography module in correct version. So here it is, and maybe in the next reviews, versions of certbot, you will also need to modify that version in case of some issues during image build. And next, of course, we have setting proper permissions for files supplied here. So we have init script, that certbot cron file, and the whole let's encrypt nginx configuration here, as you can see, available as template. And what's more, we are removing the standard certbot cron script. We want our script instead. And also, as previously for the nginx, I'm linking standard out and standard error to the log of the nginx. So it will be also available using docker logs command. And we are also using here supervisor-d, which is really simple service used to handle more services used simultaneously inside container. So when you have some simple containers, when you only start one binary, you don't need it. But when you want also to start, for example, cron daemon in the background, and you want to monitor it, so when there is some situation when it can be killed, for example, it should be restarted automatically by supervisor-d. And the rest is pretty basic. We have the init script, of course. In init script, I've commented this section responsible for changing user ID, etc., because we have the multi-container application here, and even some containers uses more than one user. So in that case, I just set those permissions differently on my DSM instead of creating more users. I will show you it later also. So what's going on in the init script? I remove the configuration for nginx, and the reason for that is we have certificates specified in that configuration, and when you first start the container, you don't have those certificates generated, and you need run nginx to be able to generate new ones. So without removing that file, nginx would just quit. Then we are just run the cron script here, and after that we can send stop signal to the nginx, and then we can use the template. I will show you in a moment that template. We can use it and change some options passed by env variables and put the final result in that file. And then we are ready to restart the nginx. And we are killing it here because supervisor D is responsible for starting nginx with default parameters. Next, we have also that configuration for Let's Encrypt for nginx. And here, as you can see, it's pretty basic, also pretty basic configuration. So we have that parameter tagged here, and it's being replaced by set command during init script. Also, you have mongo _init file here. So this is the file with command for mongo, which is needed during first database initialization. So we will use it in a moment when we have all containers started and we want to configure the whole RocketChat for the first time. So it's only needed then. We have also pull script, which is used only to get new version of the Mongo, and also it's important to get it in specific version 4.4.0 because it's the version compatible with current RocketChat application. So you can't put latest version here because it won't work. And also we are getting latest version of the Debian stable image. And for other stuff we have just supervisor dconfig, which is really pretty default configuration. You of course can check it and change it if you want. And in supervisor directory conf.d we have just two files, one for cron and one for the nginx here. And that's it for that directory. And the rest is located in the RocketChat server bundle subdirectory. In that one, we can see just the Docker file, which is the only file needed to build the image with the pre-built application. And that file is the same file as used in the stock image for the RocketChat. So I hadn't prepared all those options. I just got the file from the official image and just modified some variables. And the important one here is the node version here, because as developers changes the code for the RocketChat, that version could change also. And without updating that version, there can be moment when the application just stop working. And if that is the case, you will need to increase that version. Of course, it's easy to Google what version you need. So you have really a lot of stuff here, and the one place I've added is to copy that pre-built application to the app directory. So after that, it's being built, and that's the whole part for the RocketChat server. So now we can try to build all those containers and also start it. And we will then pre-configure our RocketChat server. And I will also tell you a little about redirecting ports also, and what you need to also do to be able to use Let's Encrypt, because that's not all. So now I will use manage and update option to build those images and start those containers for RocketChat. Now, of course, I need to specify the application name here. So we have finally images built and also application running. I have also 3 important points right now. First is I've forgot to prepare the directory for the config for the RocketChat, and as you can see here, it's not present. And on the Linux, it's not a big deal because Docker will create those directories and subdirectories. But of course, when you want better control of permissions, you should create it yourself, and we will move to that in a moment. And the second one is you can still use stock RocketChat Docker image, and you don't need to use that image and container I've showed you before to bundle the whole application, to build it. And even the second one here to prepare container with that pre-built image, you can also use the stock one. But here is the more flexible, more complex, most complex way of doing that. It gives you possibility to fix stuff even before developers can fix it. But for now, of course, RocketChat is pretty stable, so most of the core functionalities work properly. So you can switch to the stock Docker image also. But you have alternative. I still use, for example, those that way because I have greater control over the whole process here. And the third point, you should also configure your own DNS mask on the server or on the NAS device where Docker service is placed. And the reason for that is, let's see, Docker network ls. We have that mid-GC network, and that network uses built-in DNS resolver built into Docker, and is the specific one. And that resolver, of course, in the default configuration will use probably your router DNS server or your internet provider DNS server. What is the issue here? The issue will occur when you run your server, your NAS, and you will try to restart your router. So the main DNS is unavailable. And then it is really often situation when that built-in Docker DNS stops working. So to prevent that, I use DNS mask, and that DNS mask uses the DNS on the router. And for that, I configure the whole Docker to use that DNS mask on the Docker host itself. So it's worth mentioning, and I will also show you that in my next videos. So as you can see, we don't have the configuration directory, and those containers will probably restart indefinitely, or they even couldn't been run here, as you can see. So let's fix it, and for that we will log in to DSM Web UI, and we will create those directories and set proper permissions and owners. So I will open to File Station Windows. In that we will see the previously prepared configuration, and in that one I will create the new configuration. So first we need to create directory and subdirectories. And for Mongo also 2 subdirectories, config.db and db. And when we have all those directories created, we can check owner and permissions. It will be quite similar to the previous nginx reverse proxy configuration, but with slight modifications. So as owner, I can set root user here, but I don't have the root user. I don't have the root user, but I can do that from the console. RocketChat. And now as you can see, root user is the owner. And for permissions here, we should use the configuration that we should allow Docker tag group here. Docker tag, full control, deny users. So users deny, full control, and also owner should have full access, because even if you have root owner here, the subdirectories could be the application could change the owner of subdirectories, so it's important to have it set up properly. And also we have read for everyone. Reads. And it actually should be deny for, of course, for Docker tag here. So we will change it to deny, and we will apply those settings to also to all sub directories. Yes, and also we can check these those subdirectories, but here we have the same level of access. So it should work. We will just see. So here also all those permissions are being inherited. So now we are ready to restart the application. So we will use create rerun option here. So we will recreate all containers and start them again. So let's see all containers. As you can see, containers had been started correctly that time. We can also check those directories. They had been populated, so it works. And right now we can also use that MongoDB script to init database for the RocketChat application. So we will use docker exec ti RocketChat MongoDB1 bin bash. We will also switch to the MongoDB user. I will also check. Yes, the database runs on the MongoDB user. So to preserve correct permissions, we should switch to that user. And now we can start Mongo and just paste those commands. And as you can see, it worked. So that's it for the MongoDB. And you will also do that only one time during first database initialization. You can also check logs for the application here. So we have RocketChat app1, and probably we will have to wait for the database. You can also check here. Yeah, it's bad gateway. In the meantime, I can show you also logs from the Let's Encrypt proxy. We have it here, so you can check if certificate had been processed correctly, and as you can see, it had been correctly processed. Also, you can see it in the browser because it's the valid certificate, not self-signed one, which is important, especially during usage with Android application, because Android by default won't let you use self-signed certificates. So this is important. Let's get back to the application. As you can see, it's initializing. It should start in a moment also. Okay, so as you can see, the main application had been started correctly. Now I will switch to the browser and refresh the page. And now I have the first configuration screen. So I can first set up my administrator. So for that I will type masters of the code user, username the same, code, organization email, you can paste anything you want. And password test1234 for that. And continue. Organization type, non-profit, name, masters of the code, industry, technology, services, or technology provider. You can choose whatever you like. And the website, masters of the code club.com. There's a typo. Masters of the code club.com. Continue. Site name. Masters RocketChat, let's change it. Language default, server type, private team, and we will disable two-factor via email. And I want to keep standalone. Okay, so now I have it pre-configured, and we can also check in General tab here that we have correct site address. It's important especially for Android application later. And we also have here some additional options and also restart server. Really useful feature. Let's get back to the console and let's check that Docker PSO. As you can see, I have some ports redirected here, and you can of course change those ports yourself. And the most important port here is the port for the Let's Encrypt reverse proxy. So it's 21443 here, and that port needs to be redirected on your router to be able to reach the service from outside. Of course, you also need proper domain to be set up, so when you go to that domain and port from outside, it will work correctly. So that is the easy part. But also there is another thing important. Okay, and there is additional part for Let's Encrypt to work correctly, and I have it here because I use Apache here as my main HTTP server. You can of course also use, for example, nginx, but the rule is the same. So I need the file which is named correctly, so it's being processed before the, for example, default configuration, where I have my main domain without subdomain, for example. So the config for the main domain, for example, here, because either way it won't be parsed correctly and it won't work. And why is that important? Because Let's Encrypt works only on the port 80. So it assumes that for your domain, something listens at port 80 and is able to ensure that you are the owner of the service and sends back the acknowledge message to the Let's Encrypt. But in that case, of course, I have one domain, for example, with subdomains, but services that run on different ports. So in that case, I need to use proxy pass. Is the same like reverse proxy for nginx, a module for Apache, to pass all requests from Let's Encrypt to my RocketChat nginx reverse proxy, which runs on my Docker here. So for that I use proxy pass, and I need just to pass one file here and in that subdirectory to same one on that nginx reverse proxy, and I use IP for that and port by which I can connect to my nginx reverse proxy. And it is mandatory configuration here. Without it, Let's Encrypt is unable to work properly. Also, you need to open the traffic on the firewall, and in that case you should do that on the server when you have the main HTTP server, like I said. And in that case it's being connected by unencrypted VPN service in that subnet to my virtual DSM, because as you can see here, we have that that tune device with this subnet. So it will depend on your specific configuration, but you have to take it into account. And also for other services like Jitsi Meet, it will also need to be done. Okay, so now we have the RocketChat server pre-configured. So what we may want is also the application for the Android, because of course you can use the browser web UI for RocketChat and also get notifications using browser on the Android, but it's better to use dedicated application for that. But it's not that simple also, because on the Android, if you want to use Google Firebase messaging notifications, you need to register your own application. It's not that difficult. You can Google also about it. I of course prepared already my application, and the stuff you need here, you will need that public facing name, and in that you will have the project hyphen and that ID. So that ID is needed for the RocketChat, and on the next tab, cloud messaging, you have something like server key. That is of course my Firebase console, as you can see. So you have that server key, and those two parameters are needed for RocketChat to be able to pass those notifications for Android properly. So let's get back to the RocketChat application, and the configuration for that is located here on the push tab. So we have that default configuration. So in default configuration, it will probably want to use the RocketChat default gateway, but we don't want that. We want those notifications to be handled by our server only. And as you can see here, it's all grayed out, and we can't change it. And to be able to do that, we need to, unfortunately for now, we need to switch for a moment that consent. So we need to go to the setup wizard and set it properly. Setup wizard, cloud service, privacy, terms agreement, save. And also we will probably need to change some other options. We can register server. I will also set it back to the previous value. It's only needed for configure that push part here. I don't want to use gateway, so now I can disable it. It's really strange, I can't do that other way, but it's how it is. And now when I have those fields, I can go back to the setup wizard, and I can switch those options to the previous state, and now I can use my own server as a gateway. It's pretty strange. Probably in the code you can also switch it other way. And now I can also put proper configuration here, as you can see. So I have API key and project number and the server key. Okay, and we will save the changes. And the last part for that server application I need to do is restart the whole application, and I can do it easily from the general tab. I could also restart the container, but we will use that option here. And we can check logs under the container, under the console. Okay, so application had been started, so I can relog in, refresh the page. Oh, and for the test purpose, I'm also going to add some additional user. We will use it to test the Android application. So I will put tests in all fields, password also test, nickname test, and I will put the user in the default user group, which is also important. So the user is being able to use some basic features. Yes. So the user had been created, and we can also verify it here and log into that new user. Great, so it works. So I will relog in here for the administrator. Okay, so now we are ready to see how to build the Android application and how to connect it, and you will see the whole example. Okay, so right now I'm going to build that Android application, and also I'm going to use the same image and container to start Android emulator and show it to you. So I don't have any container running, but I have image here already built, so I will use docker rmi to remove that image, and I will also remove image used to build the server application part. Okay, so we have it removed. I will switch to the Android part directory here, and we have that Android part here. So I will also tell you something more about it. I've already showed you the action script for it, but other than that, we have also the whole build script here. And what we have here. First, we are cleaning the previous RocketChat directory, and we are cloning the current stable branch, as you can see. And what else we need to do is remove that Google Services JSON files, and that is the part of Android configuration when you need to configure your project ID. I've previously also used to configure RocketChat server application. Maybe I will start to showing you the whole Docker file here. It's pretty complex, but you need the whole SDK, whole development environment from Google here. So that is why we need that. We need a lot of packages here. So as you can see, we are installing standard packages using apt-get, but also other packages using just the HTTP repositories. We are also preparing that same user and putting it in KVM group, so we are able to run also the emulator from inside the container later. And also you can see here you need to specify SDK tools version here and also other stuff. Sudo file is the same as for the server part, and other files which are deployed also are Google Services, Gradle properties, that build script, the key, and the key store here should be set up once, and you should use this key store later to sign your APK files. That way you will be able to easily upgrade Android application later without need to reinstall the whole application. And we also have the translate Python script, which uses Google Translate API, and that one is used to supply not natively available languages to the application. So when there are languages you want and they are not available by default, you can configure that script so the whole translation is automatically done. Of course, if you only want the English version or you use other languages that are present, you don't need that file, and you can also remove it from the build script. Then we will switch to the master user and pre-configure some other stuff. Basically, it's the whole stuff needed to get working Google SDK inside the container. And this is also the reason why the image for that container is that big, why the image has around 11 gigabytes. Here we have part, we have to accept licenses. as you can see, and we are installing proper components also. And here is the also part for creating some default Android virtual machine, Android emulator, and some basic options that are needed later to be able to use, for example, keyboard properly. And next part is for NVM. We are installing and exporting proper paths also, and we are executing the basic part of the build script, because you have CFG only option passed here as parameter to that script. And also we are linking and pre-configuring other files. And as for server image, we have sleep infinite option as the command here. So let's take a look also at the build script again. Maybe first let's take a look at translate script. It's pretty basic, simple script. It uses some standard module for using Google Translate API. And here you have the definitions. You need to specify two files with the English language and as the destination, the file you want to replace. Of course, you can even add additional language here, but for the simplicity of code changes, I've just used some other language which I replacing using that script. And also that script should be prepared for some special tags inside those files. So for that, maybe I will just cut it and show you that language file. Of course, I need to build the image and start the container first. But in that file anyway, we have special tags which shouldn't be translated. So that part is handling that, and also is handling hanged API calls. So we are retrying in those cases, and that's it. We are getting the translated file for the application on the output. And maybe also we should check the Gradle properties file. So here we have some pretty basic configuration for the key store and passwords. So you can either change those passwords and regenerate or generate your own key store file again, or you can use those passwords in the key store file also. Other than that, we have also that Google Services JSON file, and as I mentioned, we need that key here, and that's project number. So we have the project number here, so you can get it from the Firebase console. Of course, you have Firebase URL, project ID, not number, project ID, storage bucket, and other parameters. All of those parameters you can get from the Firebase console, and even if you Google for it, you can just generate that specific file automatically from Firebase Google console. So you don't need to build it yourself. You can generate it and download and put it here. Okay, so that's it. We can get back to that build file. So as you can see here, you have some additional stuff, and you can just skip the set and the translate script if you don't want additional translation for other languages not natively supported by the RocketChat Android application. And at the end, of course, we have the assemble release command here, and that option is of course skipped during image build. So we can now start it. You have also the run sh script, and the run sh script is a script designed to start the whole container with the privileged mode and with some additional options. And using it allows you to start the Android emulator inside the container and tap to the same X server you use on your, for example, on your laptop. So it's a good option to test something. We will use it also later, but first we will use action build command to build the Android image with SDK and other tools. So finally it had been built. It took a real amount of time, and you won't see it here because it's greatly speeded up, but it took a lot of time, and also a painfully slow process is translating those language files. So if you don't need it, you should remove it, because I use here free of charge Google API method, so it's slow. And also, once again, in the Docker file, when I will search for key store, you have that line here, but it's commented, and that line is responsible for generating key store file. So for you should first time comment that line here, so you don't have the key store file at the beginning, so you can't copy it here. Instead, you should comment that line here and uncomment that line here, and that way you are able to initialize the key store file, and after that you should copy it from inside the container, from inside the image somewhere, to be able to provide it later when you are creating the new image, the new container, because that way you will be able to update your Android application nicely. So I will skip those changes here, and we are finally ready to assemble our Android application. So I will use assemble option here. So when we have Android client built, I can check that no container is running. We can start one right now using run script. So let's use it. And also you can see that we have latest package with the Android application built here, RocketChat master APK. So I will copy that APK file to the container home directory of the master user. Let me check once again. It's chat1. Okay. And now we can tab into that container. We are in the home directory here, and I can also take ownership of that APK file. So you have some warning for sudo, but it works anyway. As you can see, it has the proper owner right now. And also I can start emulator because we have that alias to be able to start the emulator easily. It's defined in bash rc file, so you can check it also here. So you don't have to type that longer command, and you have the emu_start command instead. So the emulator will start. And we will need adb command with install parameter and the name of the APK package to install that package on the emulator. Of course, I'm showing you that on the emulator, and you can boot it on your proper Android device, so phone or any other device. The emulator is just good for testing stuff. So let's install it, and then inside we will have to type that full domain name for the RocketChat and port, and also test user and test password in a moment. Okay, so it's being installed. You can see it here. And we can connect to our RocketChat server. RocketChat NAS masters of the code club.com and port 21443. I will check it once again here. It's correct. Connect, and we can log in with our test user. Test password also. So we have only general channel here, not any direct messages yet. So let's start one from the administrator, masters of the code user here. So direct message for test user. So you can see we have notification and the message had been properly sent. You can also, like previously, send back some message also. As you can see, it also works. I can also try to point you in the right direction for finding how you can create your application. It's Google Firebase console. So let's try it. Google Firebase console, how to create own application. So let's Google something like Google Firebase console, how to create own application notification for Android. So you have everything here. So how to create Firebase project. You can also see how to download that JSON file, and also other settings you need. So everything is here. So that's the only stuff you need to do to be able to get notifications in your own Android application and RocketChat server also. So it's being quite long video. I had to show you a lot of stuff. I hope you enjoyed it. So remember to hit bell icon to get notified about my future video. Also about Jitsi Meet. I will show you in that video how to integrate Jitsi Meet with RocketChat. Thank you for watching. Bye.